This lecture we'll study about what are dependent sources, how we can solve the circuits with dependent sources using mesh analysis and nodal analysis. As we know that a voltage source is indicated with plus and minus symbol. Okay, if it is encircled with if this plus and minus is encircled, it is called as an independent voltage source. If you place plus and minus within this diamond shape or rhombus shape, then it is a dependent voltage source. If an arrow indicates the current flowing through a particular branch, so arrow within a diamond shape indicates it is a dependent current source. If the same arrow, if you draw within the circle, it is a independent current source. So this is an independent current source. If you keep the arrow within the diamond shape, it is a dependent current source. There are four possible dependent sources or controlled sources. So first one is it is a voltage source, but the voltage across the source depends upon voltage across some other branch. Second is voltage controlled current source. It is a current source. The current given by the particular source depends upon the voltage across some other branch. Then it is called voltage dependent current source or voltage controlled current source. Let us take it is a dependent voltage source, but the voltage across the source depends upon current flowing through some other branch. Then it is called current controlled voltage source. In the same way, let us take this is a dependent current source, but the current in the particular source depends upon current flowing in some other branch of a circuit. Then it is called current controlled current source. If you take one simple practical example, the students who are in general, students who are doing undergraduate studies, okay, the amount of money they will spend per month depends upon the parents' income or pocket money given by the parents. Sources, operational amplifier is a very good example of voltage controlled voltage source. The output voltage of operational amplifier depends upon difference between the input voltage. In the same way, you can take one simple example. By varying the regulator which is there, you can vary the speed of a fan. So once you vary the regulator, automatically the voltage applied across the fan will increase, thereby the speed increases. So in many control circuits, in many control applications, the control logic can be represented with the dependent sources. So how we can indicate current controlled voltage source or current dependent voltage source? So the voltage source is indicated with plus and minus symbol placed in a diamond shape. Now, as I said, it is a voltage source. It is going to produce a voltage between the terminals C and D. But the voltage across C and D depends upon current flowing in some other branch. So it is simply like Y is equal to Mx. Whereas X is a current, Y is a voltage. So what should be the slope of a line? Obviously using Ohm's law, slope of the line is resistance. So current controlled voltage source is the voltage across the two terminals depends upon current flowing in some other terminal. For example, the current flowing in this branch is 0, then the VCD will become 0. If current flowing in this branch increases to 2, then the voltage across the dependent source will become 2 into slope R. If the current increases to 4, the voltage produced by the source will increases to 4R. So a current dependent voltage source is represented with plus to minus rhombus symbol, and the voltage across this is given by one constant. You can represent it with R multiplied with I. Let us analyze current controlled current source or current dependent current source. So it is just like Y is equal to M into X. Here Y is also a current. Let it is I1. and X is also a current which is I2. So obviously the slope of a line, if I1 and I2 both are in amperes, the slope of a line is a constant. It does not have any units. So let that constant is indicated with beta. Okay, so the current flowing through this particular current source depends upon I. So if I is equal to 0, the current given by the current source is equal to 0. If the current flowing in this branch increases to 2 amperes, then the current given by the current source will increases to beta into 2. In similar fashion, if the current increases to 10, then the current source will give a current of beta into 10. So it is a current source. The value of current given by the current source depends upon the current I which is flowing in some other branch. Next, we will see voltage controlled current source. So basically it is a current source. So it is going to give the value of current I. The value of the current depends upon voltage across some other branch. So let the voltage is VAB or V. Okay, let the voltage across this branch is V. So it is nothing but Y is equal to MX, where Y is current. Okay, it is a current source. It is depending upon the voltage V. So obviously, if you take Ohm's law, so this I by V is nothing but 1 by R. So the slope is a conductance. The slope is a conductance, and the units of the slope is 1 by R. Okay, so let us indicate the slope of the voltage controlled current source with the conductance. So the voltage across this particular branch, sorry, the current flowing through this current source depends upon voltage across this particular branch. If the voltage across this branch is 2 volts, then the current value will become 2 into G. If the voltage increases to 4 volts, the current flowing through the current source or current given by this current source will increase to 4G. If voltage across this will become 0, the current given by the current source will become 0. So it is called voltage controlled current source or voltage dependent current source. Current source therefore indicated with arrow within the rhombus. As it is voltage dependent, the slope is becoming conductance. Last one is voltage dependent voltage source. That means voltage across C and D. VCD depends upon voltage across the terminals A and B. Okay. So if you consider Y is equal to MX, Y is equal to MX. In this case, Y is also voltage and X is also voltage. So V1 is equal to M into V2. So obviously the units, M does not have any units, it is a constant. Let that constant is indicated by mu. Okay, so if this is very much practically, if at all you want to see the control circuit, small amount of voltage given to the amplifier or a woofer, it will amplify the voltage by 10 times or 20 times. We can consider amplifier as voltage controlled voltage source. If you increase the input, the loudspeaker will amplify the small signal into large signal, and it can be audible to large number of audience. So how much it is going to amplify, what is the increase in the voltage depends upon the mu. For example, let us consider it is 100, mu is 100. If input voltage is 2 volts, the voltage across the dependent source will become 200 volts. If the input voltage is reduced to 1 volt, then the voltage across the dependent source will reduce to 100 volts. If we increase the voltage across the branch A and B to 10, the voltage across C and D will increase to 1000 volts. So therefore, it is called as voltage dependent voltage source or voltage controlled voltage source. Let us try to solve a problem with a dependent source. As soon as you will see the problem, first you need to identify whether it is a dependent source. whether the dependent source is a current source or not. By seeing this diagram as it is an arrow within the rhombus shape, first I can say it is a current source. It is a dependent current source. So the current value is given by 2 into Ix. That means Ix is the current flowing through 2 ohms. So what it is? It is a current controlled current source. That means the current flowing in this particular branch depends upon the value of current flowing through this 2 ohms. So in a given problem, there is one dependent source. That dependent source is current dependent current source or current controlled current source. So as you can see in a given problem, it consists of current sources and the resistances. So we can go for a nodal analysis. So let us consider this node as a reference node. Then remaining nodes are V1, 2, 3. Let us assign the voltage, first node voltage as V1, second node voltage as V2, third node voltage as V3. As you can see in figure, after assigning the voltages V1, V2, V3, let us assign the current directions. So no need to assign a new current because already in a problem he has mentioned the current flowing through 2 ohms is Ix. So let Ix is flowing through 2 ohms. Let I1 current is flowing from V1 to V3 through 4 ohm resistance. Let I2 is the current flowing from V2 to V3 through 8 ohm resistance. Let I3 is the current flowing from V2 to ground through 4 ohm resistance. So we need to solve the problem very much similar to nodal analysis problem. So what are the steps involved in nodal analysis? First, identify the reference node, then identify the node voltages, define the node voltages as V1, V2, V3. After that, assign the currents flowing through each and every branch. Step 3 will be write a KCL equation at each node. So when you are writing the KCL at each node, so whatever is Ix, we are going to keep as it is, but we are going to define Ix. So what is Ix? Ix is the current flowing from V1 to V2. So Ix is equal to V1 minus V2 divided by 2 ohms. Wherever there is Ix, we are going to replace that Ix in terms of node voltages. So let us analyze or let us first apply the KCL to node 1. What is the incoming current? 3 amperes is the incoming current. What are the outgoing currents? Ix and I1. So applying KCL, incoming current is equal to sum of outgoing currents. After writing the KCL equation, we have to represent these currents in terms of node voltages. What is the I1? I1 is the current flowing from V1 to V3. So what will be the formula? V1 minus V3 divided by 4 ohm resistance. Then what is Ix? Ix is the current flowing from V1 to V2. Okay, so V1 minus V2 divided by 2 ohms. There ends writing the nodal equation current at node 1. Let us write a equation at node 2. If you carefully observe, the incoming current at node 2 is Ix, outgoing currents are I3 and I2. So if you write a KCL equation, incoming current Ix is equal to outgoing current I2 plus I3. After that, we need to write the currents in terms of node voltages. As I said, Ix is the current flowing from V1 to V2. So V1 minus V2 by 2 ohms. Whereas I2 is the current which is flowing from V1 to V3. So it is flowing from, V2 to V3. So V2 minus V3 divided by 8 ohms. Whereas I3 is the current flowing from V2 to ground. So V2 minus 0 divided by resistance 4 ohms. There ends the nodal equation at second node. Okay, let us write the nodal equation at third node. So if you take a third node, the incoming current is I1 and I2. So if you apply the nodal equation or else if you apply the KCL at third node, it is I1 plus I2 is equal to the current. You write down it is a current source, outgoing current. You can write down it as 2ix. 2ix. Now what is I1? I1 is the current flowing from V1 to V3. Okay. So I1 will be V1 minus V3 divided by 4 ohms. What is the I2? I2 is the current flowing from V2 to V3. So V2 minus V3 divided by 8 ohms, which is equal to current source. It is a dependent current source, current dependent current source. We write the magnitude as it is. Ix is the current flowing from V1 to V2. So V1 minus V2 divided by the resistance 2 ohms. This is the equation number 3. If you simplify the equations and write down in a matrix form, okay, so then you'll have a 3 equations, V1, V2, V3. Let us solve a problem using mesh analysis with a dependent source. As you can see in a given problem, it consists of one independent voltage source and one dependent voltage source. We need to determine I0 using mesh analysis. From the circuit, you can see it consists of 3 meshes. Let the mesh current for the first mesh is I1, mesh current for the second mesh is I2, mesh current for the third mesh is I3. Okay, and as you can see within the rhombus, it is plus and minus. So it is a dependent voltage source, but it is depending upon current. So it is a current controlled voltage source or current dependent voltage source. The voltage across this branch depends upon the current flowing in 10 ohm resistance. The current flowing in 10 ohm resistance. If this is 0, the voltage is 0. If this is 2 amperes, it will be 8 volts. If this is 10 amperes, 4 into 10, 40 volts. So this is a dependent voltage source. It is a current dependent voltage source. Okay. So we need to determine I0. Let the currents flowing through mesh 1 is I1. Let the current flowing through mesh 2 is I2. Let the current flowing through mesh 3 is I3. So first we need to write a KVL equation for the first loop or first mesh. So if you traverse from this node to this node, you are encountering one voltage source. So we can take it as a minus 24. Then if you encounter this resistance, no need to write down I1 minus I2 because this is a current source. Okay, so let us write down it as I0. So you can write down either 10 plus 10 I0. Okay, so if at all you write a KVL equation for the first loop. Okay, so apply KVL for each mesh. For the mesh 1, if you travel from this node to this node, first node to second node, so it is minus 24. And 10 ohms is common between first mesh and second mesh. Let the current I1 is flowing in this direction. And if you take a clockwise for I2, I2 is flowing in opposite direction. As discussed in mesh analysis, write down the resistance value. In mesh 1, assume I1 is greater than I2. So 10 into I1 minus I2. Similarly, this 12 ohm resistance is also common between first mesh and third mesh. So we can write down first 12, assuming I1 is greater than I3. So 12 into I1 minus I3. 12 into I1 minus I3. This is the first equation. Now coming to second mesh. So apply the KVL second mesh. So it is 24 is only belonging to second mesh. So 24 I2. 4 is common between I2 and I3. So plus 4 into I2 minus I3. And 10 is common between second mesh and first mesh. So 10 into I2 minus I1. So first 24 I2, 4 is common between second mesh and third mesh. So write down the resistance, assuming always I2 is greater than any other current in opposite mesh, I2 minus I3 plus 10 into 10 is common between second mesh and first mesh. So I2 minus I1. On simplifying, it will become minus 5I1 plus 19I2 minus 2I3 is equal to 0. Now let us apply a KVL equation for the third mesh. So if you apply KVL equation for the third mesh, as you can see, 4 is common between third mesh and second mesh. So 4 into I3 minus I2. 4 into I3 minus I2. And 12 is common between I3 and I1. So first write down the resistance, assuming always I3 is greater than I1. So 12 into I3 minus I1. Now, when you are flowing through this particular mesh, you are encountering, we should treat it as a voltage source only. The voltage it is when you are when you are flowing in a clockwise direction, you are touching plus. So we are using a plus. And what is the voltage value of this dependent voltage source? 4I naught. So we are writing 4I naught. Now, we have to replace or identify what is this I naught. Can we represent this I naught in terms of mesh currents? See, you can observe I naught is the current flowing through 10 ohms in downward direction. Okay, so this is the current flowing through 10 ohms. So what is the current flowing through 10 ohms in downward direction? I1 is flowing in downward direction in 10 ohms. I2 is flowing in upward direction in 10 ohms. So we can, by observation, we can say current flowing through 10 ohms is I naught, which can be represented as I1 minus I2. I1 minus I2. So we can replace this I naught in the above equation with I1 minus I2. If you rewrite this, you are going to get three equations in terms of I1, I2, I3. So represent the three equation in a standard matrix form. So it is 3 by 3 matrix multiplied with AX is equal to B. So you can use a Cramak's rule to find out I1, I2, I3. So, but the problem in the problem he has given about I naught. So how you can determine I naught? I naught is equal to small I1 minus I2.